Welcome to MPA Infracore. This is a YouTube channel aiming to provide educational videos. If you like the videos, please subscribe the channel for upcoming updates. In this session, we will talk about geosynthetics. Geosynthetic is made of fabrics polymer with a appropriate tensile, elongation, as well as strength, which then uses into the subgrade as well as asphalt layer, permeable drainage material, separation of subgrade to subbase material, and various other purposes. Types, basically we're looking for geogrids, geotextile, geomembranes, geonet, and geocomposites. So these are the 4 different types of geotextile. Geogrid, as you can see, is a polymer fiber strip attached together, and the geogrid uses for soil reinforcement and asphalt overlay. Geotextile, it can be non-woven and woven. As you can see on the screen, the woven, non-woven having a different texture. Woven is different fabric texture. So it is a fabric of material which is non-woven, and application can be soil reinforcement, asphalt overlay, erosion sedimentation control, separation layer between the subgrade and subbase, filler and drainage application, and that varies based on a project's and its constraints. As you can see, this non-woven geofabric, different colors. The first, in the white, is a UV protected. Second, black texture comes without a UV protection. Geotextile also is a woven, which is used for soil reinforcement and asphalt overlay. Geomembrane is a member of a polyethylene sheet, which is having application of soil reinforcement and asphalt overlay. So, and the fourth one was geonet and geocomposite. It is a mixture of geonet, geogrid, as well as geomember together, which called as a composite, and it has an application similar to the reinforcement, asphalt overlay, drainage, and filtration material. So these are the 4 types of geotextile, geosynthetic we have used. We have gone through geogrids, geotextile, geomembranes, geonet, and geocomposites. So I will just go through a short geotextile overview, which is being used in a rural road construction, and once you go through the video, I will provide some of the points which need to be considered for road reconstruction projects like this. So let's just jump in and start this video.
Has given an unprecedented boost to this long-lasting technology that offers multiple advantages. Geosynthetics has proven to be very good material for improving the properties of the subgrade soil. And among the geotextiles also, geosynthetics also, coir geotextiles is one material which is having a lot of potential. And if you take these geotextiles, we can have the natural geotextiles or artificial geotextiles. Artificial geotextiles, which are made from the polymers and all those things, they suffer from the problem due to UV rays. But in case of the natural geotextile, that problem is not there. And among the natural geotextiles, we have jute geotextiles and coir geotextiles. And jute, if you combine these two again, coir geotextile, which is made from the coir fibers, is better because of the higher strength of the coir fiber compared to the jute fiber. And also, the life of the coir fiber is more than that of the jute. This coir geotextile is made from the coir fiber, which is again an agriculture product. So, you can say that it is a renewable one. And also, the growing of the coconuts and all the things will bring more of livelihood for the farmers and all the people. So if you encourage the use of the geotextile in the road construction, then it will have a lot of indirect benefits, not only for the road construction but other benefits also. Now, if you use the geotextile in road construction, it can be provided anywhere in the structure of the pavement. But generally, it is preferred to provide above the subgrade. And if it is provided above the subgrade, it will act as a reinforcing material. It will also act as a drainage material. So it will perform many functions in addition to these two, and thus enhance the life of the pavement. Generally, we have a feeling that the geotextile is a biodegradable. And after some time, the geotextile, once it degrades, it won't be available there. So it may not perform the function what it is supposed to. But the life of the geotextile is more than 5 years. So during this 5 years period, whatever has to happen in the pavement, that will happen. And the subgrade and other layers also will get strengthened. So after the 5 years or 6 years period, even if the geotextile is not present, as it would have degraded, there won't be any problem. So it will retain its strength as it is. So by using the geotextile, we can reduce the total cost of the construction.
Second session, as you can see, the road construction is being progress. This is a typically rural road. Density of the ADT, average daily traffic, is unknown. The aim here is how geotextile made up from coconut fabric is being used in a road construction process. So you can see on a screen, subgrade is being prepared and tested for dry, density and compaction. Roller is used as a steel wheel roller. Moisture content has been measured to achieve the optimum compaction, and here we can listen ahead just in a, regarding to the process of road construction using coconut geotextile.
For above, then that is good. Other if it is coming below, that is poor compaction or less than 100%. So once again, we have to apply the watering that is to be made the optimum moisture. Again, we have to reroll. So whatever we tested is exactly 100%. So we are getting a good compaction over here, and it is ready for the subsequent layers. That is, we are going to place the geotextile above that. Clearing the subgrade is followed by rolling out the first roll of coir geotextile using one of the edges as reference. The second and third rolls are rolled out in the next stage, maintaining the required overlap. Special attention is paid to ensuring the removal of folds and wrinkles. The rolls are then fixed to the subgrade by using clamps after folding for a small length at the beginning and end of the roll. And also at the curves and slopes in order to avoid chances of movement. The geotextile needs to be folded properly, not for full width, to account for the difference in length along the two edges, inner and outer, of the roll curves. Thereafter, each roll is tied at the overlaps using cable ties in the spacing of not less than 1 meter. The next stage is about the preparation of the subbase. For this, the lorry tipper is brought to the tip of the geotextile and the material dumped over it. on the geotextile is to be very carefully and consciously avoided. The dumped material is then evenly spread, either manually or mechanically, by using the JCB to the design thickness. Then the profiles are corrected manually for the required camber and super elevation. A roller is then used to roll the material to 100% compaction. After finishing the GSP layer, the shoulders are maintained with good gravel earth for spreading the grade 2 material as base layer, the width of which is 3.8 meters. This is dry rolled to the required compaction, and the screening material is applied to fill in the pores. Water is sprinkled over and it is then re-rolled. The next stage is spreading the binder earth on the surface, which is water rolled as per specifications. With this process over, it is allowed to cure or dry for a few days before the commencement of next stage. The grade 3 layer is then spread in the same manner as grade 2, and the screening material is again applied to fill in the pores. But at this stage, instead of binder earth, slow setting bitumen emulsion is applied as prime coat for bonding. Above this base layer, rapid setting bitumen emulsion is applied as tack coat, followed by 20 mm thick premix chipping carpet using natural rubber modified bitumen or NRMB or BG30 grade bitumen. Finally, a seat coat using the same bitumen is spread over to finalize the surface layer.
So,